So in our third video looking at transformations, we'll be focusing on translations, and we'll be going through how and what is meant by a column vector, how we can translate shapes using a column vector, and how we can describe a translation using a column vector. Now there are some practice worksheets attached in the description which I thoroughly recommend that you use as form of practice. Now translating a shape involves moving a shape horizontally, vertically, or a combination of the two. So as you can see in the diagram on the screen, we've got a triangle that has been moved from A to B or B to A. Now an important question with regards to this is which shape is the object and which is the image. So which shape was the original shape and which one has been, let's say, transformed or translated in this case. And this is a key example of why vocabulary is really important. Now with regards to this, now we asked the question of which shape is the object and which is the image, and what we need to do is we need to look at how things are written. Now A to B means that you are starting at A and you finish at B. So A is the object and B is the image. Now if you had it written so that you had A from B, then here we start at B and we finish at A. So B here is our object and A is our image, and it's really important. And the key, also another key factor with translations is, as you can see from the diagram, that the triangle has not been altered in any shape or form in terms of size. So the dimensions are exactly the same. So the base of that triangle is 1 for both those two, and the height of that triangle is 2 squares for both those two triangles. And also another key thing to note with translation is that the orientation or the position of the triangles has not been altered in terms of how it looks. So you can see that you've got the sort of base that's on the top and you've got the height that's more on the right hand side. Now to describe a translation we use what we call a column vector. Now it sounds more complicated than what it actually is, but what it actually is, it acts very similar to a vertical coordinate commonly used with square brackets. So you'll get something that looks like this. Now the square brackets is kind of optional. It's more mathematical for you to use square brackets because it represents a column vector, not a coordinate, but we can treat it in a very same way. Now your A value is like the x ordinate, and what the top value describes, and it describes the horizontal movement. So in other words, whether we're going left or we're going right. Now the B value acts very similar to the y ordinate, and this describes the vertical movement. So in other words, whether we are going up or down. And that's the key thing to remember. So if you kind of remember it as, let's say, like coordinates, A is always the left right movement and the bottom number or B value is always the up down value movement. So let's have a look at what is going to be commonly asked for you. So in an exam, in a test, or in a classwork or homework, when you're looking at translation, you're typically going to be asked one or two things. So you'll either be asked to translate a shape using a column vector, or you'll be asked to describe a translation using a column vector. Now when translating a shape, all we're doing is simply moving the shape to a different location, and when describing a translation, the key thing to remember here is you use the word translation. So you should be able to spot whether when a shape has just simply been moved location, and if it has, make sure you use the keyword translation, and then you follow that up with a column vector. So let's have a look at describing the movement. So before we move on to actual questions involving shapes, let's have a look at what these column vectors actually mean. So what we're going to do is we're going to describe in words what these column vectors actually represent. So 2 represents the horizontal movement. So the key thing to look at here is if I just do a little set of notes, so that if this number is positive, then we're moving it in this direction. If it's negative, we're moving it to the left. If it's positive, we're moving it up, and if this bottom number is negative, we're moving it down. And let's just put a little bubble around that to describe what we're doing. And the number refers to the number of squares or number of places. So with regards to number 1, this is moving 2 squares to the right and 4 squares up. For question 2, we're moving 6 to the left and 5 up. Now one way to kind of remember this is if you imagine that you've got a set of axes in which we've got y and we've got x. So looking at the x, our positive values are on this side and our negative values are on this side. And if you look at the y-axis, our positive values are going up and our negative values are going down. So it's kind of like another way of looking at it. So if we continue with regards to question 3, so here we're moving 1 to the left and 7 down, because we've got negative 7. For question 4, we're moving 0 movement left or right, so no left or right movement. And we're moving 4 squares up. Now another way of saying that you can just say is just 4 up. For question 5, so here we're moving it 3 to the right and no up down. So in other words, we could just write for number 5, we could just say just 3 to the right. And again, the numbers refer to the number of squares or the number of places, depending on what you're working with. So with question 6, we're moving it 3 to the right and 10 down. For question 7, we're moving it 7 to the right. Now you can end up with decimal numbers, so it's 2.5 places to the down. And for question 8, we're moving it 3 to the right and 5 down. And for question 9, we're moving 0 left right, or in other words, no left right, and we're moving it 5 places down. So like I said, you can kind of decide which one's which, but you've got to make sure and treat these questions like a vertical coordinate and understand what a positive top value means, what a negative top value means, and what a positive bottom value means, and what a negative bottom value means to decide what movement you've then got to do. So let's have a look at some actual shapes. So in this first set of examples, what we're doing here is we're translating a shape using a column vector. Now, as I've said, the key thing here is now our shapes that we've got are the original shapes. So we've been given the objects and we need to create the image, translation image. Now for this, what I'd recommend that you do, and I'm hoping that you can see the shapes quite clearly on your screens. So for question for this first one, which I'm going to do in green, is we're looking at shape A and we need to move this 1 place to the right and 4 squares up. Now what I'm going to do is, now shape A looks like this. I'm just going to go over it. Now again, I strongly recommend with all types of transformations, make sure you are using rulers, and apologies because I'm not setting a very good example. Now to make your life a little bit easier, just pick one point. Now shape A is not that bad in terms of complexity, so I'm just going to pick one point in shape A and I'm going to use this column vector of 1 to the right and 4 up. Now it doesn't matter which way you do first, whether you move up first or to the right first, but let's just have a look. So I'm going to move it 1 to the right, so that becomes there, and I'm going to move it 4 squares up, so that's 1, 2, 3, 4. And so that new position is just there. Now from here, what I'm now going to do is I'm just going to copy that shape. And again, trying to be as accurate as I can. Again, should be using a ruler. So this shape here is my image of shape A. And there we go. Now if I use a different colour, let's go for orange. So with regards to B, let's just make that pen a little bit thicker. So with shape B, I'm moving it 7 to the right and 7 down. So with shape B, I'm going to pick a point. So I'm going to pick this point here. And again, let me just go over the outline of that shape. So here we've got a trapezium. So from here, we're going to go 7 to the right. So I'm going 1, 2, 3, 4, 5, 6, 7. And then I'm going to go 7 down. So 1, 2, 3, 4, 5, 6, 7. so that becomes there, and then from that point I'm just going to trace that shape. So I've got a height baseline of 2 to that point there, and there we go, and this is my new B. And let's just label these. Now when you have got an image, we can just usually put like A dash, and this would be B dash, just to show that that there is the image of B. So little dash basically means like a little eye, and so we're looking at those. And let's just make that pen a little bit thicker. Alright, so coming on to our last shape, so let's go for purple for this one. So again for C, we're moving it 8 to the left and 4 up. So with C, let me just go through an outline of C. So again, I'm going to pick a point on shape C. I'm going to move this point 8 to the left. So 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go 4 up. So 1, 2, 3, 4. So that's my starting point. And then all I then need to do is just copy that shape from that point. Now when you have got a grid that looks like this, and again I'm just going to shade that in, and I'm just going to call that C dash, and that's A dash. Now one thing you could do is that when you have got a grid or a set of axes that you can do this, is what I could do is pick, let's say if I look at shape A, now the coordinate I've marked is -6 and -2. Now I want to apply the vector of 1, 4. So, and because they're positive, I'm going to add 1 to -6, so that becomes -5, and I'm going to add 4 to -2, and that becomes +2. So that point on A dash is going to be that there. Now if I look at this, -5, +2 is this point here. So even if I wasn't to count the squares, what I could do is use coordinates and apply the column vector to that coordinate that I've chosen on the original shape, on the object I should say, and we can go from there. And so either or. Now I would say counting squares is going to be a lot easier for you, so I definitely would recommend doing that. So then let's now have a look at describing a column vector. Now again, the key word is reading the question carefully. So look out for words of going from A to B and understand the difference from B from A and those types of variations. Now in this particular question you can see that we've got a lot of triangles. So again, importance on reading the question carefully is going to be really important. So let's just make this question a little bit bigger. And let's move it up. So there we go. Right, so the question says to describe the translation vector, you must always use a vector. So what translation vector which takes shape A to shape B? Now again, to make your life a lot easier, pick a point on shape A and the same point on shape B. And what I'm going to do is I'm going to work out the directions going left to right first. So here I'm going 1, 2, 3, 4. So that's going to be +4 because I'm going to the right. And I'm going to go 3 squares down, so that's -3. And let's just show that there. For question C to A, or C onto A, so I'm going from this shape here to there, so I'm going from C to A. So again, I'm going to pick this shape here, so for this I'm going to need to go to the left, so it's 1, 2, 3, 4, 5, 6, 7, 8 to the left, so that's -8, and I'm moving 1 square up, so it's +1. Now if you want to write +1, that's entirely up to you, you're not going to lose any marks for it. And again, another thing that I've noticed on this question here, we've got curved brackets. Again, doesn't really matter. So some worksheets will have square brackets, some will have curvy brackets. Again, sometimes it's based on what's easier to type up on a computer. And then finally, for this third one, we're going from G onto F. So here I'm going to pick a point on G, so I'm going to go for the top point, and I'm going to pick the same corresponding point on F. So again, going left to right first, so this I need to go to the left, so it's 1, 2, 3, 4, 5, so it's -5. And then I need to go 1, 2 down, so it's -2. And there we go. Now, obviously, when you've got an exam in a test, you won't have loads of shapes. You may do, but you tend to find these types of questions are very, very popular on worksheets or textbooks or online websites and where you're practicing this particular topic. But typically in an exam, you'll only get really one shape, and then you'd either have to draw the image based on the column vector, or you would then have to go on and describe it using a column vector. Now, when you are describing, make sure you use the word translation. Again, I can't stress that enough. Loads of students tend to forget that. They just do the column vector, and you'll get a mark for the correct sign of the number of places and the correct sign for the number of places going vertically as well. So always make sure your numbers, it's always worth double checking on those. And another key thing is recognizing when a shape has been translated or reflected or enlarged or rotated. So always make sure you're able to spot what a translation looks like. And just a reminder that there are plenty of practice worksheets attached in the description.